Okay, here we go again. Let's do an example straight from the book. Here's what it says. It says the inverse cosine. It's in a capital C, so it means you're going to be in our restricted area. And let's say negative a half. Okay? Now, we just quickly talked about what the restrictions are for the cosine. Let's jot it down. This is what I would do. You guys are watching, right? All right, so it's the inverse cosine. So we're restricted to what two quadrants? First and second. So this is, you may not see any teachers do this, but this is just something I just came up with. It's not that big of a deal, but I like to just mark them all so I know I'm not in here. Now let's think about this. The cosine. We got to find the angle. Which quadrant are we going to? We have an option of either the first or the second, but it's the cosine of a negative. The inverse cosine of negative 1/2 has to be in the second, right? Because in order to get the cosine to be negative a half, then you have to be going to the left. So even though first quadrant is part of our restricted area that we can use, we're not going to. Why not? Because the cosine is negative. Cosine can't be negative in the first quadrant, can it? So we move to the second quadrant. That kind of narrows things down, doesn't it? Now let's think about it. Let's just think of our, like, it's not, James, what's the word? It's not the terminal angle. It's the, you know what I mean? It's the reference angle. For some reason, I forget that word. Okay, it's the reference angle. So let's think of in this quadrant right here. Where is the cosine of half? Well, the cosine's going this way, right? So it's going to be the short side. So what would the reference angle be? It would be 60, wouldn't it? Okay? Do you see that? So that would be 60 right there. But it's not really 60 because it's in the second quadrant. You follow me? Because that's negative a half. So it's 60 degrees. We don't put 60 degrees here. We start from here and we go to there. So what would that angle be? That'd be 120 degrees. Okay? And that's our angle. Remember, we only want one answer, don't we? All right, so we just put that one answer down, and that's 120 degrees. They use, yeah, they use radians. But again, I really should, but I've told you that we'll just wait till next year. Yeah, we'll just keep everything in degrees. Is that all right? I'm probably babying you a little bit, but we just need to move on, and I'm just going to stick with degrees. All right. So, but next year, remember, you'll probably be doing stuff in radians. So, but today we'll just stick with degrees. All right, so it's 120 degrees. Does that make any sense? Do you see what I did? I started off drawing my little x and y axis. I marked off my areas where I know it can't be, and then I look at the two possibilities. It's the cosine was negative, so I know I'm going to be in my second quadrant. What if it said inverse cosine of positive 1/2? Then what quadrant would I be in? I'd be in the first quadrant. I'd mark off the second one. Do you see that?
All
right.
Are they always going to give you one of those special ones?
Yeah, these will all be special ones. Yeah, absolutely. They're going to get, I mean, think of the numbers. You got square root of 3 over 2, you got square root of 2 over 2, you got a 1, you've got square root of 3 over 3 for tangent, right? You got square root of 3. Remember all those numbers? So all those numbers, and I told you before, you had to memorize that stuff, right? So all that should be coming to your memory. And it's just kind of like going backwards, isn't it? Instead of saying, okay, what's the cosine of 120? It's saying, okay, what's the angle if the cosine was negative a half? And that's what you're doing. You're just kind of going backwards. Let's do another example. All right, here's another example right here. Arctan of negative square root of 3. So I draw my little x and y axis. This doesn't have to be perfect. You don't have to, it doesn't have to be dead on or anything. It's arctan. So the inverse tangent or the arctan is restricted to what two quadrants for the tangent? First and fourth. So I like to do this. I like to mark that one out. I like to mark that one out. Now the tangent of that particular angle, we don't know what that angle is just yet, but the tangent of that angle is going to be negative. So we have to be in the fourth quadrant. Can you get the tangent to be negative in the first quadrant? No, because opposite over adjacent is going to be positive up here. So what can I do now? I can mark off that one. Okay? And again, I've never seen anybody do this. I just came up with that. I don't know why, but I did. Now, we know we're going to be in the fourth quadrant down here. Let's think of the square root of 3. Which angle comes to mind when you think of tangent and square root of 3? You think 60 degrees, don't you? All right? So that's our reference angle, right? 60 degrees. So let's draw 60-degree angle just like this, just to give us a basic idea what's going on. So that would be 60 degrees, correct? And look at it. It's opposite over adjacent, or y over x, correct? This is negative, this is positive, so that's negative, yeah. And the tangent is right there. So we could say negative 60 degrees, couldn't we? If you wanted to refer to it as that. Or if you want to write it as a positive angle, what would that angle be? 300 degrees. So 300 degrees. And that's it. You get one answer, right? You don't have a whole bunch of answers. You don't go around in a circle a bunch of times. You only have one answer, and that's basically what you do.
Would -60 also be the correct answer?
You could say -60. It's the same thing, unless like on the homework or whatever, they say make a positive answer or something like that. But -60 would be fine. All right. I think for the most part, my guess is, let me see what they wrote for that one. Where is it? They actually did say -60 on that one. Okay. But that's fine. Either one of these are perfectly acceptable. I really don't have a preference. Yeah. We okay with that? That's not too hard. Let's do a different style of problem, okay, if we're okay with this. Here we go. All right, here's another style of problem. It kind of looks the same because you got the inverse cosine, you got the capital C, but look what they did to this. They stuck a tangent out in here, okay?
You have a lowercase tangent in capital.
Yeah, exactly. Because look, remember what this is. When you find the inverse cosine or inverse sine or inverse tangent, what are you finding? You're finding an angle, aren't you? That's right. So you're finding an angle here, and then they're going to take the tangent of that angle. Okay? So you find out what the angle is, and then you just take the tangent of that angle. That's all they're doing. It's not a whole lot different, is it, than what we were just doing. So what are you going to do? Let's do this. We'll do this right here. Yes, it is. And let's just go through the beginning. We draw our little x and y axis. It's inverse cosine. So we got to think of our restriction. Which one was the cosine? The cosine was one by itself, right? The sine and the tangent were the ones together, had the same restrictions. The cosine was the one with a different restriction. And what were restrict? If I could speak, what were I can't say we and re together. What were we restricted to the All right, for the first and the what? Second. All right, so I mark this one out, mark this one out. Now it's positive. Where is the cosine positive, in the first or the second? In the first. Finally, we use one in the first, right? The other examples, we didn't go in the first, so we get rid of this. So a half. What do? Are you watching? So a half is the short side, right? So what angle? Right, and you might be able to just visualize this in your mind. At some point, you should be to that point, Maybe not right now, I don't know, because it's fairly early since we've done this. I would draw it if I were you. But some of you guys can absolutely think about where that's going to be without even seeing it, okay? So, James. All right, so it's 60 degrees. So this right here is 60 degrees. But we're not done. Our answer is not 60 degrees. What are we trying to do? We're trying to find the tangent of 60 degrees. Now, that should be something that's memorized, shouldn't it? It's just the square root of 3, and that's it. Now, watch this. What if you weren't sure about this? You could do this. Actually, for that one, let's just do that. We know, and I told you, you should memorize what the tangent of 30 is, tangent of 60 is. So I would just go with that and say, that's our answer. That's all they want you to do. Now, they did it in a calculator. I do not want you to do this in a calculator, okay? On the example in the book, they put 1.7, whatever, 1.73. I don't want it in a calculator. I want an exact answer. You follow me? All right, so make sure that you do that. I mean, anybody could just put that in a calculator, but I want you to be able to know what's going on and know how to get that. All right, let's do another one. Okay, here's a different situation. Now, if you look at this, on the other one, that was an angle we could just find. It was one of our special angles. Well, what about 3/8? Is 3/8 one of our special ones? Nah, it's not square root of 3 over 2. It's not a half. It's not 1. It's not square root of 2 over 2. It's not square root of 3 over 3. It's not square root of 3. It's none of those, right? So we don't know what 3/8 is. But watch what we do. It's not too hard. It might even be a little bit easier. I don't know. We'll see. Let's do our restriction thing. Okay, we do this thing first, don't we? Tangents restricted to the first and fourth. So we get rid of this, get rid of this. It's positive. Where's the tangent going to be positive, in the first or the fourth? It's going to be in the first, because it's going to be negative down here in the fourth. You understand? We're going to be in here. Now watch. This is what I do. I draw. You don't even have to be to scale. I just draw any angle in here and drop me a triangle to the x-axis. Okay? Don't know what this is, do I? Trying to figure out what that is, because that's what I'm trying to find right here. Now watch. If it's the tangent of this angle, it's 3 over 8, which is opposite over adjacent. So which side is opposite? This one. So that's going to be the 3, and this is going to be what? the 8. Now, what are we trying to find, though? Watch, the cool thing about this is I don't really even have to find what theta is equal to. You don't need to put it in a calculator. You don't have to figure out what the decimal approximation is. What we're trying to do is we're trying to find the sine of this situation, aren't we? Okay, I just reverted that to theta, right? So I set up my situation. How in the world do I find sine of this? I take the opposite over the hypotenuse. Okay, in interest of time, I just did the work right here. So the sine of theta is opposite over hypotenuse. All right, we figured out what the hypotenuse was by Pythagorean theorem. There's the work. So the sine is the opposite over the hypotenuse. I change it, I rationalize the denominator, change it to a decimal. The answer in the book is a decimal because it doesn't come out to a nice, perfect number. You could keep it like this or like this. Either way is perfectly fine. All right? All right, there's the homework, 874, 12 to 29.